All right, today we're going to talk about how to use congruent triangles in order to show that all the corresponding parts are also congruent. So let me remind you, when we first studied congruent triangles, if I create two triangles, let's say I have ABC, and this one I'll call DEF. And so if let's say for example that angle A is congruent to angle D, and angle B is congruent to angle E, and maybe we also know that AB is congruent to DE. So judging what we've studied, I can tell that the following two triangles are congruent by angle side angle. So I have just shown that triangle ABC is also congruent to triangle DEF. And all I did to show that was I showed one angle, one side, and one angle. But going back to the basic definition of congruent triangles, even though I only talked about the one angle, the one side, and the other angle, all of the other parts are also equal. For example, I also know that AC is congruent to DF because I just showed the triangles were congruent. I know that the other side that hasn't been discussed. I know that segment BC is congruent to EF because based on the definition of triangles, all the parts are equal. And I also know that third angle, that angle C is congruent to angle F, all because triangles are congruent. So we call that, we don't really have a theorem, but it's a rule that we use to show that. And that's what we're trying to discuss today. So what I want to do with this first example, let's mark our congruent parts. Let's mark AB is parallel to DE. So put your markings on there. Let's show that AB is congruent to DE in the given. Now I'm trying to show that C is the midpoint of BE. Before I can do that, I have to, number one, show or prove the triangles are congruent. Prove the triangles are congruent. So we're going to informally do that by just marking and noticing things. So I have a side right now. I can also show that my vertical angles are equal. So I can mark those two equal, and I'm just going to write here vertical. Because of parallel lines, I have a set of congruent alternate interior angles. So I can show that A is congruent to D, and I'm just going to jot down alternate interior angles. So that right there gives me enough to show triangles are congruent by angle, angle, side. So I want to go ahead and name the triangles. So I am going to just start the first one off. So I'm going to call it ACB. So triangle ACB is congruent to, and you would need to name it in the proper order. So since I started with A, I'm going to have to start with D. C in both triangles are congruent, and then that leaves me with E. And we did that by angle, angle, side. So in order to show that C is the midpoint of BE, I need to show that segment BC is congruent to segment CE. And I know that's true already because if I've shown the triangles are congruent, all their corresponding parts are equal. So I also know that segment BC is now congruent to segment CE. And the reason I know that is what we're going to now use to show it's congruent. And I'm going to write a sentence out, but we're going to shorten it up as an acronym. And so I know that because corresponding parts of congruent triangles are congruent. And instead of writing all that, we're going to use the acronym. We're going to use the CPCTC. So in a proof, I would be able to write BC is congruent to CE because it's CPCTC. Now to finish out my example, now I know C is the midpoint of BE because of definition of midpoint. Okay, but we'll get to that in a later example. Okay, let's look at the next one. Tell which triangles you can show are congruent in order to prove the statement. What postulate or theorem would you use? So I'm trying to show that JK is congruent to LK. So I don't know that it's congruent, but I need to first show triangles are congruent. So on my picture, I see that JM is congruent to ML. I have angle JMK is congruent to angle KML. So I also can mark my reflexive. Let's mark our reflexive. Now I know the triangles are congruent by SAS. So in order to answer the question, which two triangles am I proving? So name the first one, and then arrange the letters in the second one in the correct order. So I might start with J, go down to M, and up to K. So triangle JMK is going to be congruent to, well, J is going to correspond with L. The two M's at the bottom are equal, and then back up to K. And I did that with SAS. Okay. So this right here would answer my question. Tell which triangles I need to show congruent to prove the statement. And the postulate or theorem would be SAS. Okay, let's do the next one. And what I'd like you to do is maybe read the directions and pause the video and try to do this next example, and then come back in and we can check answers. Okay, so I'm trying to show why RPQ is equal to TRS. So that information I can't use to answer the question. I want to prove the triangles are congruent and use one of my rules. So I see a side is congruent to a side. So I'm going to use, oh, and I've got an angle over here congruent to an angle. I'm going to have to use these parallel lines to find some congruent angles. So if I were to extend them out, here's your transversal. I have a set of corresponding. This angle right here corresponds to the angle below. So that does give me enough to have congruent triangles. So I have an angle, and I have a side. So you can name your triangles a number of ways. One way to name it would be, erase some of these markings. One way to name it would be, I'm going to start with the top triangle, PRQ. Triangle PRQ is congruent to triangle RTS. Now you could rearrange the letters and write something different but be the same. Another way, I could start with R. So maybe I could say RQP is congruent to triangle TSR. That would be also correct. And again, I could continue to rearrange. So there's going to be a number of different answers you could write as long as you line up the correct angles. Oh, the reason I didn't write down, the reason would be angles, it would be angle, angle, side. Right angle, angle, side. Okay, let's get into some proofs here. So we are trying to prove that angle S is congruent to angle U. We're going to get our givens off of the diagram. So I'm going to use those tick marks to be my givens. So set your two columns up. And then when I list my givens, I'm going to name the two sets of sides congruent as my givens. So one of them can be segment SB is congruent to segment UT, and then the top and bottom. Segment ST congruent to BU. So feel free to pause the video or rewind, fast forward as you need. Okay, my goal here is to, number one, show the triangles are congruent. So I can add my reflexive. So step two, I'm going to talk about the reflexive. So segment BT is congruent to segment BT, reflexive property of congruence. And I now have enough to show my triangles are congruent. So I have to name them in these proofs. So I know that triangle, so just pick a name for the first one. I'm maybe going to start with S. S over to T over to V. So STV is congruent to, so if I start with ST, I'm going to have to start with UV. So UVT. So one thing to look at, my reflexive segments are in the same spot. TV and VT, those are the same thing. So my reason is SSS. And so because the triangles are congruent, all the other pieces are equal. So now I can now show that S is congruent to U. So line 4, I'm going to say angle S, congruent to angle U, and this is because of that corresponding parts of congruent triangles are congruent. C, P, C, T, C. So I'm still going to end my proof with the proof line, but I need to show triangles are congruent, and then I can continue on to C, P, C, T, C. Okay, one more proof. Get your columns set up, and we will continue on this one. And go ahead and enter givens. So I have a segment and an angle. So segment NM is congruent to segment PQ. And then I can just call it angle N and angle P since it's not attached to another triangle. Angle N is congruent to angle P. Those are given. So my goal is to show the triangles are congruent. So when I look at my picture, I see some vertical angles. So I'm going to mark the vertical angles, and that's going to be my next step. So the top one I'm going to call angle NLM, congruent to PLQ, vertical angles congruence theorem, or just vertical angles theorem. Vertical angles congruence theorem. And I now have enough to prove triangles are congruent. I've got angle side. So you have to name your triangles, and we could have differences here but still be correct. So I'm going to call this NLM. Triangle NLM is congruent to triangle, that would have to be PLQ. And it was angle side. So I'm trying to show that a segment is congruent to a segment that I didn't include in my proof. This is my corresponding parts line. So I am able to now finish with that sentence. Segment LM is congruent to segment LQ by corresponding parts of congruent triangles are congruent. CP, CT, C. Okay, so if you need to go back and watch any of that, that's fine. At this point, if you want to stop the video, then you can get started on the assignment.